Hey everyone, welcome back to this Python series. My name is Ansh Pathania and today we are going to learn the core concepts, the most important topic of Python, functions and recursions. So without wasting any time, let's get started. Okay, so let's start with a problem every programmer runs into when their script goes beyond 20 or 30 lines. Code redundancy. So first, let me write a code. Let's assume here is 50 lines of code, and at the end let's write a second calculation. X is equals to 20 and y is equals to 30. Sum value 2 is equals to x plus y. Print the sum is sum value. Before we look at the solution, let me ask everyone in the room or in the chat. Look at these two blocks of codes. If I tell you that my client wants to charge the printed message from the sum is to result is, how many places in my code do I have to manually edit right now? 2, right? Now what if this script had 2000 lines and performed calculations in 20 different places? Write your answer in the chat. Now, in software engineering, at companies like Google, Microsoft or Amazon, senior developers perform code reviews on everything you write. If a senior engineer sees you repeating the same 3 lines of logic in multiple places, your pull request will be instantly rejected. They will write one comment: dry. Dry stands for don't repeat yourself. Repeating code causes bugs because when you update one section, you inadvertently forgot to update the other 39 places. Think of a function like a vending machine. You don't rebuild the inner gear of a vending machine. Every time you want a snack, engineers build the vending machine once, which is a function definition. Whenever you are hungry, you press a button, insert coin, which is an argument, and the machine hands you a snack, which is a return value. Today we are learning how to build our own software vending machine. So let's start with function autonomy and return versus print. So first let me run this code. It will run. This is just an example of why we need functions. So in Python we create a function using the def keyword followed by the function name parenthesis for parameter and a colon. So let me show you how to write a function here. Let me show you the syntax. So we can define function by def, and let's take a name of function, calculate sum a comma b. Result is equals to a plus b, and return value is result. Now this is the function definition. Let me write in comments. Function definition. Okay, now we have to write the function call. Output 1 is equals to calculate sum of 5 and 10 and output 2 calculate sum of 20 and 30. Now I want everyone to open your VS Code or online compiler. Type out def calculate sum. Notice how Python automatically indents the next line by 4 spaces. As you can see here, the indentation. I can give 4 spaces. This is exactly, you can use tab or you can give 4 spaces. 1, 2, 3, 4. These both are exactly same. Now if your code is not intended, Python will throw an indentation error. Always respect the indentation. So let me show you. It will throw an error here. Yeah, as you can see, the compiler has thrown an error, indentation error, and if I give the indentation, wait guys, there's missing something. Oh, I used, now it will work. So now let's address the single biggest point of confusion for beginners. What is the difference between print and return? Let's write an experiment live on the screen to prove it. So first let's write, okay wait, this is the function, as I told you before, this is the function definition and this is the function call. Now let's, so experiment A, def function with print A comma B, print A plus B. Let's do experiment B, def function with print with return A comma B. Now let's return A plus B. As you can see, in the first experiment I have used print function, and in the second experiment I have used return. So now we have to call the function here, function with print 10, 20 val b is equals function with print 10, 20. Let's print sto are stored in val a comma val a. Val b and val b. So now let's run the code. There is a name error now. func missed. again, if you in C function, not will work. Yep. So wait guys, there is an error, I think so. Def function. Val A stored in val A. Oh, now it will work. So now look at the terminal output here. Val A prints none, and while val B prints 30. Why? Now think of print like a TV screen. It displays information for human eyes to see, but then that information disappears into thin air. You cannot save the picture on a TV screen into a box. Think of return like courier service. It physically hands a package, you can assume data, back to your variable so you can use it later in your program. Save it to a database or multiply it by another number. So return will print the value, the actual value, and the print function will give you none value. So let's move to our next part 3, built-in versus user-defined functions. So Python functions are divided into two main categories: built-in function provided out of the box by Python, and user-defined function created by us. So let's take 2 minutes to list built-in function you have already been using without realizing they were functions. So let's start. User name is equals to Ansh. Marks is equals to 85, 90, 95, 100. Now let's use functions. Oh. Yeah, you can do no. Let's take print sum marks. Notice how we didn't have to write for a for loop to add 85 plus 90 plus 95 plus 100. Python code developers already wrote a hyper-optimized function called sum, written in C underlying Python. When you write user-defined functions, you are extending Python's capability so that future developers on your team can reuse your work just like built-in functions. So we have used len function, type function, max function, and sum. Now moving on to the next topic, default parameters and positional syntax rules. Sometimes we want to give parameters a default fallback value. in case the user forgets to pass an argument. So let's understand how to do that. Def, first we are making a function. Multiply a comma b is equals to 1. Return a into b. Print multiply 5 comma 4, and let's write 7. So as you can see, this is how you can use default fallback values. I have in the first I have written multiply 5 comma 4. So the value of a here is 5 and the value of b is overwritten by 4. So if we multiply 4 into 5, 5 into 4, it will give 20, as you can see in the output. And if we didn't give any value to b, it will take the default value 1 from the parameters. So if you multiply 7 into 1, it will give 7. So this is how it works. And now intentionally break Python to understand a crucial syntax rule. What if I put the default parameter first? So let's understand. What if equals to 1? Now let's run the code. Now look at the error line in the editor. Syntax error, non-default. Argument follows default arguments. Why Python is so strict about it? Let's trace it logically. If I call bad multiply 5, here I have written multiply, you can give bad multiply. If I call multiply 5, Python gets confused. Did you mean a is equals to 5 and forget b, or did you mean b is equals to 5 and want a to stay 1? To remove this confusion, Python enforce the golden rule: all non-default parameters must come first and all default optional parameters must come at the end. Let's write 4 full practical strict step by step. Now let's understand this concept by practice problems here. Our first problem is to find average of 3 numbers. Write a function, calculate average a, b, c, and that takes 3 numbers and returns their average. Simple. Now I am giving you 60 seconds on the clock. Just pause the video and after that I'll solve. So let's solve. A, b, c. Total is equals to a plus b plus c, and average is equals to total divided by 3. Return average. Print average calculate average 10 10 comma 20 comma 30. Okay, so let's run the code. Yep. As you can see, it is working. The average of three numbers 10, 20 and 30 is 20. This is a very simple code. These are very simple problems. Let's move on to the next problem. Next problem is printing list elements with end. By default, Python appends an invisible new line at the end of every statement. Let's see how changing end let's just output a whole list on a single line. So first make a list. Cities is equals to Delhi, comma Mumbai, comma Pune, comma Bangalore. Def print in list for item in list print item comma end is equals to, let's use this. Let's print end. At last, calling the function print inline cities okay. So as you can see here, I've created a list of cities: Delhi, Mumbai, Pune, Bangalore, and after that I've created a function called print inline, and after that I have used for loop here for item in list, and I've used end function here, and I've explained you how end works. As you can see in the output also, at the end of every line, every city, it will end with these minus sign, these two minus signs, and at last I have called the function. Now moving to our third practice problem. So our third practice problem is USD to INR converter with real world rates. Let's build the currency converter function. We'll pass USD amount and as the argument and use a default argument for the exchange rate. So let's start. Def convert USD comma rate is equals to 83.5. INR is equals to USD into INR. rate return if dollar USD is equals to rupee INR. Okay, so print convert USD 100 print convert INR. Oh, USD 100,84. Should run our code. There is a name error. Convert USD. Convert. Oh, let's change here. Again, there is a name error. Conversion. Now look up here. I'll change space here. Now, as you can see, we've created a USD to INR currency converter. We have defined a function here, def convert USD. USD comma rate. Rate is the default argument, default parameter, and on second line we have written the formula here. INR is equals to USD into rate, and after we have used return here, and at last we've called the function. Okay, so now let's move to our next part, introduction to recursion and call state mechanics. So let's understand what is recursion. What is a recursion? So a recursion happens when a function calls itself to solve a smaller version of the same problem. So let me check in the PPT if I have the diagram for recursion. Yeah. So here, as you can see, definition: recursion occurs when a function calls itself to break down a problem into similar subproblems. Now, if you can understand this by this example, factorial of 3. First, we have to find factorial of 3. It will goes like 3 into 2 into 1 into base case top. So now let's understand this by, now if you ever seen a Russian doll, you know that when you open the big doll, there is a smaller doll inside. You open that doll and there is an even smaller doll inside. But what happens if you keep opening dolls forever? You can't, because eventually you hit the solid tiny wooden doll at the center that cannot be opened. In recursion, that smallest solid doll is called the base case. Without a base case, your computer will keep opening dolls until memory runs out. Now let's write a recursive function without a base case and see what Python does. Let's write our code. Okay. Now First we'll define function. Basically it is a dangerous recursion. Every recursion is dangerous if it does not have a base case. It will give us infinite loop, print hello, infinite loop. Let's run. Wait a minute, guys. The compiler is not allowing the infinite loop, but it will work on VS Code, I think so. My VS Code is not working currently, so basically it crashes with recursion error, and it is not printing the hello, so it must be the recursion error. So let's understand this. When Python runs infinite loop, it pushes a stake frame into computer RAM memory, frame 1, frame 2, frame 3 up to frame 1000. Once memory reached, Python recursion limit stops execution and throws recursion error, which shows maximum recursion depth exceeded in compression. This is why every recursive function must have two parts: base case, which is a stopping condition, and the second one is recursive call, moving towards the base case. Now let's move on to our next part: recursive practice and stake unwinding. Let's write our two classic recursive algorithms. The first one is factorial, and the second one is sum of first n numbers. So let's start with these two problems. Def factorial n if n is equals to 0 or n is equals to 1, return 1. Return n into factorial n minus 1. Print factorial factorial of 4, comma factorial of 4. Let's run the code. So here, as you can see, this is called the recursive method. It will call itself so that it can find the factorial of 4. It will call itself until the stopping conditions, the base condition. So let's understand how it works. So first we have created a function called factorial n. Now we have used conditional statement here. If n is equals to 0 or n is equals to 1. Now first let me ask you guys, what is the factorial of 0? It is 1. And what is the factorial of 1? Again 1. So here we are telling the compiler that if the value the user is entering, if it is 0 or 1, please return 1. And On the fifth line, we are making the formula here, the logic, the main logic. Here, if suppose we have entered 4, n is equals to 4. So at the return value 4 into factorial, it will call again and again 4 into n minus 1, n minus 1, 4 minus 1, n into 3. Again it will run 3 into 2. Again it will run 2 into 1. So that's how it will work. Now let's write 0. That will give 1. Let's write 1. That will give 1. Let's move on to our next practice problem. Let's trace factorial 4 step by step on screen together so everyone sees how memory unwinds. So the calling phase, push on to call stack. First, factorial 4 returns 4 into factorial 3. So let's understand this by fact 4 returns return 4 into fact 3. Okay, now second, factorial, let me copy the upper line, it will go 4 times. Now second, factorial 3 into factorial 2, same, 1 into 2 factorial 2. Last one will hit 1. This is the base case basically. Let's write base case. This will hit the base case and return 1. Now that's how the factorial works. Now let's unwind phase which resolves value from top to bottom. Let's understand that. Fact 1 is equals to 1. Fact 2 is equals to 2 into 1, which is 3. Oh, so which is 2. Fact 3 is equals to 3 into 2, 3 into 2 into 1 is equals to 6. Fact 4 is equals to 4 into 3 into 2 into 1, which is equals to 24. This is the final value, return value. This is the final return value, and this is the process, and this is the one fact 1 is the base case. Now notice how base case acts like a trampoline. The execution goes down, hit the base case and bounce back up with the final answer. So that brings us to the end of the chapter number 6. Thank you.